Good afternoon, everyone. My name is Grace, based in Advantech, Singapore. Today, I would like to share with all of you on some Advantech I/O modules and its features. Okay, so here is the overview on how data collection being applied for smart manufacturing and smart city. As you all know, machine data collection is a foundation for smart manufacturing, and this includes deploying sensors in machine that acquire data on operational status and performance, as well as to view, analyze, and also quickly act upon some real-time data coming off, especially for the facility and utility management. And in Advantech, we have a few data acquisition module, which we also call as I/O modules for such monitoring management, be it wired or wireless. Okay, so today we will focus on both wired and wireless module. The wired Adam 6000 series, which is connected via LAN connection, and also wireless module WISE 4000 series. So I will start with the wired module first. We have two series, namely Adam 6000 and 6200. The main difference between these two modules are that Adam 6200 support daisy chain topology, while Adam 6000 only supports star topology. As you can see from the slide, right, advantage of this daisy chain topology is that the data can still auto bypass if there's one Adam in between fail to operate. The master device, which is the switch or industrial PC, can still collect the data for the last unit collected for up to 4 days while waiting for the replacement of the 40 unit in between. Besides, this can also prevent data loss as the data transmission is still ongoing. And if let's say you have some limitation in the LAN ports on site, you can connect directly to your IPC or laptop LAN ports to perform daisy chain. Unlike Adam 6000, you must have a switch to act as your master device and each Adam to connect directly to the switch. Also, the data will lost if either of the Adam fail to operate. So here are the selection guide of each Adam 6000 and 6200 module that we offer, ranging from digital input, output, and also analog input, output. So you can also find this data from our website, and there will be the data sheet provided as well. So next, I will elaborate more on the advanced I/O function. So we will start with the digital input and output. So traditionally, digital input has two states, on and off. So on top of that, our digital input module can have counter and frequency input up to 3 kHz for selected models. This is a plus point as our customer software side can have lesser task execution. And also the counter function will be handled by the I/O module itself. So when the I/O module is power off, right, there's this function of keeping last value and the data won't be erased completely. In some site implementation, when there's some environmental noise or vibration, this digital filter plays an important role as it can eliminate such external factor. So if you are doing a counter input, then this kind of external noise or vibration will cause the counter value more than 1. And this digital filter will come in to help to filter such noise or vibration. But do also take note that digital filter can cause time relay of 7 milliseconds and might result in delay of response time. As for our digital output, one of the features is that it can generate the pulse output, and you can change the duty cycle as well as to add the time delay for the DO module. Whereas for the analog input and output, there are also a few advanced functions such as multiple input and output range supported, depends on your requirement. And there's also a burnout detection for analog input where you can monitor supply current level during operation. So the previous slide was about physical I/O signals and its function. Now we will elaborate more on the communication protocol portion. So Adam 6000 has a lot of IoT features where it supports different kind of protocol, such as the Modbus, SNMP, and MQTT. Not just having IoT features, you can also do some simple logic control, such as GCL, peer-to-peer, etc. I'll share more in details in the next slide. Okay, our Adam 6000 series, right, equipped with this graph control logic, which we also call as GCL. With this feature, end user don't require to learn PLC programming because our I/O modules can do simple tasks for this. And they are also using the graphical setting to configure the logic. You can see from the table in the slide on the graphic flow and also configuration page. But also take note that our response time for this is 100 millisecond at minimum, which is not comparable with those PLC response time, which normally in microsecond. And the logic control have to be actual physical signal, unlike those programming which they can remember the previous state. Second will be the peer-to-peer function. This is very similar to the GCL in previous slide, but you can only choose either one setting between GCL and peer-to-peer for your I/O module. And also you need at least 2 modules to perform this peer-to-peer function. So when the input is triggered, the output will be triggered as well. So the controller can be removed since the data will be automatically transferred to the output module. And also based on your application, right, you can have the flexibility of channel mapping, either basic mode or advanced mode, one to many or many to one. And for advanced mode, the module at the middle here have to be either digital input or digital output. Okay, beside our I/O module also support SNMP and SNMP trap. So this SNMP is normally used by the network engineer. But also take note that our SNMP is only support up to SNMP 2.0. Whereas for the SNMP trap, when there's an alarm event, our add-on module will trigger a trap message to the backend server, where you can see the status details shown in the table you see in the slide now. Next, Adam 6000 also support MQTT client. You can find all this information from Adam utility. So I won't go in very details for each function, but basically you can set up the MQTT setting, such as a topic, public topic for the input, and also the subscribe topic on the output. You can also refer to the example from the table in the slide on the MQTT setting. So in general, Adam 6000 and 6200 series can be used for various IoT applications and cater for both automation users and IT users. So for automation users, protocol that commonly used will be Modbus, and the programming used are VB.NET library and C# programming with the SDK provided by us. You can still use other programming language such as Java, but we don't have SDK for this. So you can use those open source library to do your own programming. As for the IT users, our I/O module also support RESTful API and MQTT. SNMP also supported as well and normally used by network engineer. And as mentioned just now, we do provide SDK for VB.NET and C# programming. And the software used will be Microsoft Visual Studio. You may refer to the link below for the SDK download. So next, we will go through wireless I/O module, namely WISE 4000 and WISE 4220 series. So you can refer to this selection guide in the slide here. There are 2 variants of WISE 4000 series, which are the Wi-Fi version and also the LAN version. So our demo today, right, will be on the WISE 4012E. This model actually comes with the extension board, which you can do a mini testing on your own. Our application engineer will later show you more on the utility configuration. For WISE 4220, right, it is a modular module where you can exchange the I/O module depends on your requirement. So you can refer to the table in the slide for some selection of the I/O module. But also note that the number of I/O channel will be lesser as compared to those wired module. Okay, so this slide will show the features of WISE 4000 series wireless I/O module. So in fact, the I/O features and function of WISE 4000 are quite similar with Adam 6000 series, which we have shared earlier on. So additionally, for WISE 4000 series, it has this direct cloud connectivity where you can publish the data directly to the Microsoft Azure or any cloud web services that can support MQTT. So if let's say you want to upload the log data to the file-based cloud services such as Dropbox, you can also save as CSV file and upload to the Dropbox directly. Besides, you can also use this WISE 4000 as the Modbus RTU master because they have this RS485 on board, and you can convert the data to Modbus RTU after you have collected the Modbus data from your slave device. There's also local data storage in WISE 4000 series. So in case the Wi-Fi connection is not stable, so the data can be stored in the module itself when there's no internet. And you can send the data back to the server up to 10,000 samples. Besides, you can also edit the device configuration via AP mode and also connect 4 devices via infra mode to check on the status of each WISE module. So in this table, you can see the application and architecture on how WISE 4000 and WISE 4220 connected. The lower part is the physical signal, which are the sensor layer for machine status monitoring. You can actually have flexible network extension in your current system as it is easily to be integrated into an automation solution. And with this Wi-Fi connection, right, you can save on the wiring and deployment costs. But also take note that our WISE module currently only support 2.4 gigahertz frequency. So here you can have a close view of WISE 4220. As mentioned, this series support exchangeable I/O, so you can exchange with different I/O based on your requirement. And there's this LED indicator and detachable antenna available. The switch mode is for you to alter between the AP mode and infra mode. And also do take note that the battery socket here is designed for WISE 4210 only, and it is not supported by WISE 4220 for battery power function. As for WISE 4000 series, you can see that there's this detachable antenna for Wi-Fi version and without antenna for the LAN version. The outlook for both models are actually the same. And also same as WISE 4220, the switch at the back of WISE 4000s are for device configuration and status checking purpose. So for the demo session later, the utility configuration of WISE 4012E is also applicable to all WISE 4000 series. Okay, next will be Xuewen to proceed with the demo configuration on the utility part.
Hi, good afternoon, everyone. My name is Xuewen. Today, actually, I want to share hands-on portion for our WISE 4012E. Actually, this is our IoT starter kit, right? So if you buy our WISE this module, actually they will come with our WISE this IO module. They also will come with the USB cable, or the screwdriver, and one of the wireless SCADA USB drive, and one of the extension board will be there. So what we are saying is this is the easy to set up IoT application, right? So they will have three things you can be see that, right? If you buy the standard IO module, definitely you need to be supplied for the external power, right? You need to power source from the external, right? For this our IoT starter kit, you can use the USB micro USB port to supply the power for our IO module, right? Secondly is when you do for the configuration, right? You don't need any additional hardware. The device PC to do the configuration. One of the thing is you can use your mobile phone and laptop easy to set up for your configuration and then do the monitoring. The third one is because you are starting IoT application, right? You will need for the actual sensor, right? So our IoT starter kit itself, they will come with the extension board. We also do call the evaluation board, right? So you can use the this evaluation board to be simulate your sensor signal. So you will be see from that. This is our application scenario, right? So the bottom layer is all the sensor signal will come to our IO module, right? So you can use the handphone, laptop to monitor all the condition status, right? So this IoT starter kit is they will come with the 2 channel of the analog input give me a minute. 2 channel of the analog input, right? 2 channel of the digital dry contact input, right? The 2 channel of the relay output. So because this is the IoT startup kit, right? You need to take note of a few things, right? Our input signal, we only allow to input signal is 0 tempo. So if you have an actual sensor is using current mode, all these things, right? They are not allowed to be connected to our signal, right? So if you look at from the right side is all the terminal pin, right? All the terminal pin from our I/O module. These top two channel is for the analog input, right? This DI0 and DI1 is 2 dry contact. So these 2 channel is for the relay output. But you will see that, hey, what is the purpose of using EXT1 and EXT2? Actually, we are designing these 2 terminal is for the to supply the power voltage to our evaluation port. This is the main purpose, right? So you cannot use these 2 channels to connect to supply to the additional external device, right? You really need to be taken up for this portion. This is our power supply is using 5 volt, right? So they will share all the 5 volt to be all the equipment, our evaluation board. So for today is we are not using actual sensor. We will use this actual evaluation board to do all of my hands-on and simulation. Right. So before we start to configure configure our device, you really need to be install a few utility software for your configuration, right? So let's say for ADAM, definitely you need to be installed for the ADAM Apex utility. If you want to be configure your voice module, maybe Grace will be mentioned that we have a wide range of the voice module will be there, right? So mostly we will recommend customer to use the Advantech Voice Studio configuration software. You download and install in your system, your PC, or unless you also can be used the any web browser to do the configuration, because our wireless module, voice module. I will say that the voice module, not for the ADAM. Our voice module is that they will have the internet built-in web server will be there, but most of the web command, what configuration you still can use the web browser to do the configuration. Right. So some of our voice module, let's say they will have a micro USB port to do the configuration. So for that case, you will need to be installed USB driver, because this USB driver is mainly they're using for USB port convert to the UART port. Actually, this is one of the virtual COM they use for the COM to the UART to communication purpose. You really need to be installed for USB driver. This is for optional purpose, right? So in this hands-on simulation, I will focus on 3 protocol, right? So because we are talking for the IoT application, right? So your device have to be used by the engineer or used by the IT, right? So Chris also mentioned that most of the automation engineer, they prefer to use the Modbus protocol, right? So for IT, they prefer to use the RESTful and MQTT, right? So that is the reason I will use I will main focus on these 3 protocol in my hands-on portion, right? So in this hands-on portion, I will use some of the test tools, some of the simulation tools were used together. One of the software is the ModScan. ModScan is mainly to try to pull the Modbus data, right? This is one of the test tool software. RESTful, I will use the Postman to try to query of some of our the status of the voice module, right? MQTT is I will use the MQTT box to test for the MQTT client. But for the MQTT, if you really want to test for the MQTT, actually they have 3-party will be there, right? So one of the MQTT client, they will publish the data and then come to the MQTT broker side. Another MQTT clients will use to subscribe their data, right? So this MQTT bulk is I will use for publish and subscribe for the MQTT client. In my hands-on portion, actually I'm using is the one of the public MQTT broker from the extra third-party one. So I'm using a WISE module where we publish all the data to the third-party MQTT cloud. I will use the MQTT broker to subscribe and publish the data. Right. So I think for the slide wide, this is my my slide. So I will move on to my hands-on portion. So you will be see from this picture, right? So when you order our IoT starter kit, right? This is the box. Actually, this is the box, right? So this is the box you will be receiving over there. This is the if you buy this module, all these items will come together, right? Our I/O module, screwdriver, IoT expansion, wireless SCADA installation, the package, all the USB cable will be here, right? So this is, if you unbox your box, all these items will come together, right? So you don't need go and look for the sensor. You can use our extension board, can do all the simulation, right? So after you have done the setup, probably is your signal or your actual hardware will be like that, right? So I just step in all the iteration port will be here, right? I'm using is the 5-volt USB port to supply our I/O, the power of our I/O module, right? So I will start on my hands-on portion. Before I start on hands-on portion, I really want to explain a little bit about for the what is the label, what is the LED indicator showing on our WISE module, right? So if you so from the top view itself, you will see like that, right? So actually is if you look at for this portion, right? So this is the signal bar. Is now this is a signal bar. So this is a signal bar for the Wi-Fi signal, right? So this is a signal. What is the signal strength, signal range, whether your Wi-Fi communication is good or bad for your application, right? We will use this signal bar to be identified and confirm that your signal is good. So mostly is I always recommend customer to say that if you set up for the Wi-Fi environment, at least your signal bar 2 bar and above. So otherwise your transmission data, they will have a certain latency will be there. So what mostly is the Wi-Fi. It's not the Wi-Fi, they can make it to be real time, but because of your signal strength, they will cause your transmit data, they will have a certain latency, right? So this is one of the signal bar. If you move back to move a little bit, they will have one of the thing is that I'm not sure whether you will see is clear or not. This is the AP and infra mode. This LED is not turn on me. This now is we are running in the normal mode. Actually, is the why we are saying is the normal and the initial mode. But you will see that the label is the AP and infra, because this is just the term is the different only, right? So I will show you one picture, right? So if you turn back to the back side, right? So they will actually is the normal mode and initial mode. They are using is the this dip switch to be identified. When you power according to this dip switch condition, if you give the power supply, they will be say that okay, this is the initial mode or this is the normal mode, right? So initial mode, we call initial mode. This label is mainly easy to be remember for the engineer. Engineer is that they may not be familiar with what is the AP mode, what is the infrastructure mode, right? So they they mostly what we understand is, okay, this is the initial mode. Actually, it's the initial mode is the AP mode. Normal mode, normal mode is the, we call the infrastructure mode. This is just a term different only. But if you are talk to the IT network people, they will, they will know that what is the AP, what is the infra mode, right? So this is the thing, right? Okay, the next step is that if you turn back to our back side, this is the mode. This is the normal mode in initial mode, right? So mostly, if you try to configure your device itself, right, you definitely you have to set in the initial mode. We call the AP mode, right? So another thing is the some of the information you will need it when you do for the configuration. What information do you need it, right? If you look at from the this picture, right, you will be see that this is what's the thing. This is for the MAC address. Later, I will show you what's the purpose of you need to be remember your MAC address, right? So second thing is that if you want to be configure, let's say you want to configure using the web browser, right? You need our hardware is the web server, right? You need to be key in the IP of the your web server, right? So if you see from here, right, this is the IP of the configuration is the URL, right? You don't need to go and look for the user menu, right? So when I give the short training to a customer how to configure our module, I will explain to them, okay, if you want to be start up your application, maybe you don't need to be go through 100 page of the user menu. Some of the information you also can get it from your hardware itself, right? So this is the IP and URL link, right? So this is the web server. When you be logged into the web page, they will ask you to be key in username and password. This is the account we call the username. Account is the root. Right? Account is the root. Password is the 8-digit 0. Right? So all this information you will need it for when you are device configuration. Okay. Okay, I will this is one of the important thing is the when you do for the configuration, right? So let's say we want to use for the AP mode. Okay, I just switch off. Off is the initial mode. We call it AP mode, right? Whatever you make any changes, you have to be recycle your hardware, right? So I just remove the USB cable, right? So I just connect it back. You will be see the different, right? What's the difference? Previously, you are seeing is all the signal bar will be there, right? Actually, signal bar we call the normal mode. If you see that the signal bar is there, we call it this is you are running is the normal mode. Actual application is running. But for the AP mode, infrastructure mode, if you will be see that this LED will be on, right? So when you set it your device to be initial mode, right? You have to use our device device IP address will be there. This is exactly the same. They are labeling from the at the back side, right? So I will use my laptop to configure this device module, right? So if you because now is our hardware is the AP mode. This one is very similar to all the way we are using in our normal environment. Let's say in your home, right? You will have a Wi-Fi AP. You will have a Wi-Fi router. If your mobile phone, you want to be access your internet, right? Definitely your mobile phone, you need to be look for what is the your AP is similar to this side, right? So I just move a little bit beside. You just go in there, right? So this is your voice module, right? So I did explain to you is you need to be remember or understand the MAC address. This is the last 6 digits of your MAC address, right? So if you look at for the back side, right, you will be see that F8E, right? So this is the actual MAC address will be there, right? What is the purpose of this thing? Because let's say if you have the multiple same device, if you are set up to when you do for the setup, right? Maybe let's say you give all the power supply at the same time, right? A lot of devices will be the AP mode. So you may not be know that which device you want to configure. That is the reason in our AP mode is the first one is the model name. The last digit is your MAC address. This is the unique one, right? Will not be conflicted, right? So this one, now this one is our let's say our home router, Wi-Fi router, right? This is the AP mode, right? You need to be my PC need to be connect to your AP, right? I need to try to connect to this AP, right? So you can access all the information of our voice module, right? Actually, for this concept is the exactly is the same the way we are using Wi-Fi in your home, right? So my configuration is I'm not using is the voice studio. I'm using is the web browser, right? So I'm running is the I'm using is the Chrome browser to do the configuration, right? I just open the new tab. But you will be see that this one is connected, right? But you need to make sure before you start to configure, this one must be connected. So you will be see that what is the IP, right? All the IP is I did share to you is at the back side, right? All this information will be here. Or unless if you unbox your hardware itself, all this information you can get it from this startup, this paper, right? All this paper, all this information exactly the same, right? So our default IP is 192.168.1.1, right? So this is our default IP. But sometimes I faced one of the issue before, right? So sometimes if you type this IP, right, they will not come up this page. Maybe because your web browser is they have certain condition. So sometimes if you type in the IP, maybe sometimes you will need to be type in the /config this information, unless this web server will not come up, right? So I will not say that not all web page will have this issue, but you just need to take note a few things, right? This portion, right? Our password is the root. Our password is the account name is the root, all the small letter, right? The password is the 8-digit 0, 1, 2, 3, 4, 5, 6, 7, 8, right? This is the login, first time login page. You will be see that, right? So this is the main information you can get it here, right? One is the information. What's the information? This is all the device information, right? This is your module. Sometimes is if you're using is the right module, right? You encounter some issue, but for our technical team, definitely they will ask you, that, hey, what's your firmware you're using is now? Yes, you will need to be provide all this information to technical support team, right? This one is the quite important to find out the root cause. So because our hardware itself, they try to keep on updating new function, new features. Maybe some of the bug they also will be fixing, right? So this firmware is the very important. So this information, not just the device information. This is also you will be provide what's the firmware of your hardware is using. This one is important. The next time, if you encounter any issue, maybe you just need to share all this information to our support team. Right. So second is the configuration. Right. So now our hardware is set. Now our hardware is the initial mode, right? But for actual your application, yes, I'm not using is the just one unit, just one hardware is set. Okay, maybe you will use your home, you will set up your home network, or you will use your actual hardware to your computer network, whatever the thing, right? So you will need to configure your device IP information, right? That is the case. You need to go to the configuration page and then wireless setting, right? So now I set up. I have in my this room itself. I have one Wi-Fi AP will be there, right? So this is the one I did mention to you before, right? AP mode, infra mode. But for real application, you have to be select for infra mode. Infra mode, in terms of we call is the normal mode also, right? So this is the all the information you need to be key in. This is for the your Wi-Fi SSID, right? This is we call the SSID. This is their security type. This is their password. Yeah, for my testing, I just put it everything to be the 0. This is my all the information you need to key in. But so the next step is your device. You want to connect to which device, which AP. This is your AP information, right? Second one is your device is if you want to get all this data to try to access to our hardware is that all the devices they have their own IP, right? So if you want to run as the normal mode, we have the 2 mode you can be set up: static and DHCP. DHCP is definitely the IP is given by the given by the your Wi-Fi AP or Wi-Fi router, right? So they will give you which IP is available. They will give it to you. But most of the monitoring application, if you want to run any software, but I will recommend them to use the static mode, because if your IP keep on changing, right? Because this one is keep on changing. Your software, you will encounter some issue. Okay, this time 192.1.10 10 something, right? So the next time is changing again. Okay, so your software maybe encounter that. Okay, you cannot get any data, communication issue is coming up. So I always recommend our customer to use the static mode, right? So my AP is this is my AP IP, right? This is my AP. So I want to set up to be the one of the IP. I just find it before. So this one is available. So I'm using is the 192.168.10. This is the IP to set up to be our voice module, right? So whatever you make any changes, you just click submit, right? So this one is done for your device. You can use for your actual network. Okay, this is the first step you need to be set up in for your device. Okay, right. So I did mention to you for this hands-on portion, I will do test on the 3 protocol, right? One protocol is the Modbus. Maybe I will skip it some of the very detailed information because of time limitation, right? I just straightway move to the Modbus, all this that thing, right? So you will be see from here, right? So in our hardware itself, they will have the two channel of the input, two channel of the analog input, two channel of the digital input and relay output, right? So you will need to understand, okay, I want to read or write all this data, right? Capture all this data. You need to understand, okay, I want to read this channel of this channel. So you need to know that for Modbus thing, you need to know 3 important things, right? What is the 3 important thing? Probably is to be easier to understand. I just write it out here. One is the IP, right? You need to know that which device IP, which device I want to get the data, right? First step, you need to know that the IP, right? This is the one I did set in my configuration page, right? Second thing is for the port is set, right? So the port is set, standard Modbus we are using is the 502, right? This is the standard. So this is the port you need to understand. The third one is what is the address? No, you see this is the standard, right? You will have 2 channel, right? This is I just write down all this information here, right? How you can get all this information? You just go to our web page itself, right? So you see, you will be seen from here, right? Modbus itself. Before I move to exact addressing, I will slightly explain to you about what is the Modbus, what is the data type, right? So Modbus itself, they will have 4 data type, right? So you will be see quiet status and input status. Actually, exactly the same. If you look at from the signal side, you will be point of view, you will be see that okay, we have a digital and analog. What's the meaning of digital? Digital is actually digital is their change of the state. They only have 2 conditions. I will say that two conditions, right? So I will not say that voltage level 0, 10 or change it. So the different hardware input, they will have the different voltage level. I want to use the voltage level. So digital input is that they only have the two conditions state of the two state of the changes, right? So 0 or 1, true or false, right? So mostly it's true or false is used by the programmer, right? So so I will not go through all this thing, right? So quiet status and input status is using for the digital, right? Holding and the input, they were used for the analog, right? So why they are defining for the analog, right? Analog is the change of the state is more than one condition, more than they will have a range. What range? According to their resolution, right? They will how many changes of the value they can make the changes, right? So that kind of the value condition, we will say that this is the analog value, right? So they only have the two categories, digital and analog. Digital, they only can do they only have the two conditions, on and off, 0 and 1, true or false, right? So analog, they can be what range of the data they can be able to change that, right? So what is the difference for this kind four type of the condition, right? Why? No, digital is that they will have a input and output, right? So you why is that they can do read and write for the digital state, but input status they only can do for the read status, right? So for the analog, also the same thing. Holding register, you can do read and write, right? So input register, they only can do for the reading condition, right? So, but you just take note a few things is Advantech, any kind of the most of the Advantech hardware is we only using quiet status for digital input and output, or holding register, we only using for the analog. We only use this condition, right? I did mention to you is this is for Advantech hardware, Advantech IO module. I'm not saying for the third-party device, right? So because of any hardware vendor, they will follow Modbus, but they may not follow this standard. But you just need to take note which device you are using. Let's say if you're using Advantech hardware itself, you will be see from here, right? This is the quiet status. We will use for the input, we will use for the output, right? So you can be see from here is maybe you don't need to be read through all the user manual. You also can get a lot of information from your hardware, a lot of information from your web configuration page. You can get it there, right? So this is the two channel of the input signal, right? DI 0 and 1, right? So this is the two channel of the DO 17 and 18. Why our internal firmware is defining like that? So you see from here, right? If you look at from the our Adam is that if you look at from this hardware is that what Adam, one of the Adam is that maximum channel we are designing for the 16 channel, right? So even though they are designing is the input or output or digital input or output, they only using hopping is the 16 channel, 16 channel, 16 channel, they were hopping will be there, right? So even though you are using or not, so you see from here, right? Channel 0 for digital input, they are using is 0 and 1, right? For digital input. So they are hopping from the 16, right? So this why that is the reason our hardware designing to the DO signal is the 17 to 18. If you are using is the Adam or WISE or anything, maybe you will see that, hey, what's the addressing for the what's the addressing for the Modbus register? They're using is the 16, 16, 16. They're hopping like that, right? Okay. Second one is for the analog input signal, right? Analog input signal, we have type is the holding, right? I did mention to you, we only using two. Digital stick, we only using is the quiet. Analog, we are using is the holding, right? That is the thing, right? So you will be see from here our quiet and holding. So you will be asking me, hey, Xuewen, your hardware is you only have a two channel, right? Why you are addressing is the three? Because you see the channel for actual hardware itself, we only have a two channel, right? We only have a two channel. What is the purpose of the last address is sometimes our customer, they want to get the accurate reading or they want to do some noise cancellation. They will use one signal, one sensor signal. They will connect to a few channel. I will say that a few channel, right? So let's say they will connect to a few channel, and then our firmware is they will do for the averaging. That is the reason you are seeing is all analog input. They are addressing, they will have a tree. That is the reason. But yeah, you are connecting to the two sensor. Yeah, you only need to be address 1 and 0. Right? You don't need to use 3. Right? But for our firmware itself, they are making averaging value for the last address. Right? So as long as if you look at from my this portion, right? So UIBC from here, okay, I just put in channel 0 and channel 1. This one is for the digital state. This one is for the analog. This one is for the this one is for the digital output. This one is for the analog input, right? So I will explain to you what is these two purposes, right? So this is the Modbus address, right? So okay, we definitely we need to see that if you do for the actual wiring, right? So what is the purpose of the IO status mean? This page is they will let you to make sure your wiring, your sensor connection is correctly connected, right? So this is the after you have done all the wiring, right? All the sensor, all the connection done, right? You need to make sure you can get all this data, right? Before you try to configure your software, try to run your actual program, right? So you need to use you can use our software to make sure all the reading is correct, right? So you see, this is for the digital analog input, digital input, and the relay, right? So if you look at from here, this is the analog. Let's say if you change to your input range itself, if you see from here, right? Let's say this is our evaluation board. I did mention to you is we are using is the EXT1, EXT2 to supply the power for our evaluation board, right? So this is the variable resistor, right? So if you turn to the now, because I did test before, right? So if you look at from these 3 channel stick, right? This one have a 3 volt. This one have a 0 volt. You see from the last address I did mention to you is we are using averaging. That is the reason divided by 2 is the average is 2.0, right? This 3 address, you can get it from the Modbus 1, 0, or 1, 2, and 3, right? So you see from here, right? If you change the rotate counterclockwise, they will 4 volt is the maximum because our maximum is the 5 volt. They have a certain resistor will be there, voltage will be divided, right? So they will not get the full 5 volt. If you turn back to the 0 volt, you will see that the value will change to the 0. So if you have the evaluation board, you just use these 2. This one for the channel 0, this one for channel 1, right? You can be do for simulating. So this is the simulating for your analog signal. So even though our maximum range is the 10 volt, because you are using is the 5 volt power supply, so your voltage level will not be 5 volt. Right? So if you look at from this value, actually is this value, you will be getting, if you use the Modbus, try to read the data, you will get it this 3 value. Right? If you divide that by 3000 divided by 329 this value is divided by 1,000, you will get the 3 point something voltage will be there, right? So this is for the analog value. Maybe later I will show actual simulator to you. Okay, I will try to move for the relay output. If you see from here, right, this one is the on. You will see this LED also will be on. If you turn off, sorry, so you will see that this LED will be off, right? So this one, if you on, you will see that this LED will be on, maybe a little bit not clear, right? So you will see this LED will be on, channel 0 and 1. I'm not sure the clear or not, right? So this is the one. Okay, the third one will be the input, right? So Grace did mention to you, right? Our input signal, we can use just the normal on and off. We also can be used as the counter, right? So I set it channel 0 to be the counter mode, channel 1 to be the normal input mode, right? So if because you will be see that from here, right? Counter value is 3 because the one is I did test that yesterday before, right? Yesterday. So even though I power off this thing, this number 3 still will be there. You just give the reset, this value will become to a 0, right? So we can do some simulating over here, right? So if let's say if I switch off, you will be see this channel 1 will be off, right? So if I on channel 1, you will be see this one counter value will be on. Because why our firmware is designing the counter is we actually we get a lot of the inquiry for this counter purpose. Maybe I will give you one example, right? So why you need the counter? Maybe some of the production line is they want to be detected how many parts they have done, they have finished it, they will use as counter, right? So if you use the normal I/O, if you use for the normal I/O, their software keep on try to capture the signal. Whether signal is on, if your signal is on, they will count up 1 plus 1 plus 1. They will count for you. If you use our hardware, the counter mode, you don't need. They can reduce your software task. I will say that they can reduce your software task. You don't need to make it or when the sensor is on or sensor is off. Even though if you power off, the counter value will still be kicked in our hardware itself, right? So they will not be erased because we are right in EEPROM. So even though you power off, your data still will be there, right? So that is the configuration setting. If you want to change any configuration setting, right, you just go to here, right? Channel 0 and 1, or all of the channel you want to be the same, you just select all, right? So channel 0. So you will be see from here, right? I just set it to be the counter mode over here. If you want to use the normal mode or counter mode, you just select it, right? So the counter mode. So if you enable keep last value when you power off, your data still will be maintained and keep it in our hardware, right? So this is our I/O status, the page. Maybe I will show the using our Modbus tester software to show how we can do read and write your hardware. This is one of the software tools I'm using. This is the mod scan. Right. So I did mention to you is okay. We try to start to simulate for our input signal. Right. Our input we are using is the quiet. Our addressing is 1 and 2. That is the reason I just set it to be the data lamp 2. Right. So this software is running from my PC, right? So I try to connect which device I want to connect, right? So I'm using is the I want to try to access this one is 192.168.1.1. Even though I changed to set up all the page, all the IP will be here. All right, sorry, I share something to you. Even though I did configuration in here. Okay. I did change in here, right? Even though I set the IP, but I still using default IP because I'm not recycle this power. I didn't change the jumper setting over here. All right. So only you recycle power on of your module. They only will be changed the setting, right? All the setting will be changed, right? This is the IP. This is the port, right? So if you click OK, you will be see that this is the condition of the channel 0 and channel 1, right? You cannot be able to write it off. They want to write it. They want to change anything, right? Because this one is the input signal. If I change to the off, you will be see the off. Channel 1 is on. You will be see that this value will change to on, right? So you can be make sure your Modbus address for the channel BI channel is correct, right? So let's say we can try it from the output signal. Our output signal, I did mention to you, is 17 and 18, right? So I just put it data lamp to the 2, right? So if you just change it from here, you will see that this LED will be off, right? This LED will be off. Let's say if you change to the channel 1 to be on, you will see that this LED will be on, right? So you will see that our addressing is correct, right? So second one, I did mention to you, this is for the analog input signal. We are using is the holding register, right? So you will see from here, this one is voltage. I will say that our data is the voltage. Let's say some customer, they are using our normal, actual, not the IoT starter kit, maybe ADAM, analog module or voice analog module. You will be receiving this addressing, they will receive is the raw data. Why I'm saying is the raw data is they are not receiving voltage level. So you need to take note these two difference, right? So if you're using is IoT starter kit, your data is the voltage. If you are using is the normal actual, let's say 4012, right? Not E1, 4012. Yes, you will be receiving this addressing is you are receiving is the raw data, right? You really need to be taking note a few things. How they define all these things, right? So if let's say you are using is the normal one, right? So now I always explain to the customer is I just use the calculator mode, right? So normal our voice 4012, which if you look at from this one 4012, right? If you use this 4012, they are this same channel, all the addressing, your data is not the voltage. Will be different with our IoT starter kit. If you use this one is this one voltage level will be the same. You can set it voltage level the same, but if you're receiving data will be different because their one is the raw data. How we make it to be the raw data, right? So our 4012 is that their resolution is the 16-bit. If you look at the data sheet, 16-bit. So you can use as the size our 2 to the power 16. This is the value you will be receiving. Let's say if you're giving is 0 to 10 volt, right? 10 volt is that you will be receiving 65535 because even though your resolution is 65536, their reading range is 0 to 65535, right? So you really need to be careful what kind of the data I will giving to you. This is the data now. I did mention to you. So you will be see from here, right? Mod scan software, we can be getting all this data, right? So we just explained to you is now our DI mode is counter, right? Definitely is counter. If you're using is the counter, you will ask me, hey, Xuewen, what is the counter? All this addressing will be there, right? Even though your channel 0 is the input there, or DI channel, right? So now, because of your reading is the counter mode, so their value changer is more than one stick. So your addressing definitely will be the holding register analog value, because their stick is more than one, right? If you just go to the configuration setting, okay, you just go to the Modbus mode, you just go to the holding register, you will be see that from here, right? Okay, this is the counter and frequency. If you want to reading the counter mode, even though you are using in the normal input, but your setup configuration is the counter mode, you have to read through all this addressing, 17, 18, 19, and 20. So our counter mode is 32-bit. So that is the reason one value they will occupy two address is something like that. So your counter value is 0, they will occupy 17 and 18. So if you can simulate it will be here. Let's say I'm using is the address 4, I'm changing is to 17. You will be see the counter value. Actually is, if you seeing from here, right, 1 and so 117 we call the low byte, 18 we call the high byte, right? So you really need to replace some of your data type. Let's say if you change to the mode, your data will be like that. You see now, if you try to read the Modbus data, you need to know the device IP information, right? Device information. Second is the data type, is the Modbus address. The last one is your data type, what kind of the data type you are reading. This is the really important if you try to read any Modbus data, right? I will say that any Modbus data, because different hardware will be different design, right? This is one of my simulation for the Modbus. Right. Second is the RESTful API, right? So we did explain to customer is yes, we will provide our SDK, right? We will provide our SDK. So we also share to you is where is the download, all this link, right? Our previous the Chris training slide, they will share what is the SDK. So let's say if you really want to, I'm not sure this laptop I did install here. Okay, SDK portion, maybe I will leave it later. So for the RESTful API, right, we need to refer to our user menu. For this part, really need to be referred to user menu. So if you see from here, right, you need to download our REST user menu. You need to follow to our if you want to use the REST API, what's the URL? You want to get all this data, right? So I did explain a few things to you, right? So if you want to use the RESTful API, right, you need to know that the URL, right, HTTP, and then this is your device IP. Let's say if you're using is the 192.168.10.101, right? I did set 101. Okay, I just code it. So if you want to read the digital input value, this is the URL. Slot 0, they also will give you this is our example. When you use the RESTful, when you query the data, you must see that 200. 200 means is that their return value 200 is okay. If you see that for other number, there will be different error code. Because this is the web server REST API is the very standard. Let's say 404, you cannot be find out that directory or web page. Web server, right? They will have certain condition. You can find all this 200 or 4445, all this thing is you can get all this information from Google. You can use the Google to type it. You can find all this information, right? So from this section itself, I'm using is the Postman, right? This is the Postman. This is the icon. You can get it internet or all these things. This is a postman, right? If you double click, I think now for REST API, right? If you went to REST API, they will have a few methods you can test it. You can install any REST client in the Chrome or Firefox. I did test before. You can be installed it. You just install the add-on. You still can be use it there, right? So this one also the same thing. RESTful is we are using is the web server, right? So what information you need to do, right? This is my thing. First step you need to do for the authentication. Okay, I will share something to you, right? So our authentication, the type is we are using is basic authentication, right? Maybe you ask me, hey, Xuewen, how you get it? All this information will be there, right? Maybe you can refer to our user menu. If you are using our SDK to develop, you can get it, all this information in our SDK. Because if you install the SDK, all the sample program will install all this information you can get it from SDK, right? So this is the basic authentication. You need to be select. So username and the password is the account. You need to key in root your password. Our default password I did mention to you, 8-digit 0. Let's say if you change to different password, you need to use your password, different password, right? So this one is for the authentication, right? Second one is this is the method. This is what we call the content. What kind of content you want to get your REST API, right? So this authentication, even though you use this one, header this is the one we are using. Application slash h data. This is our application content used for our voice module. You really need to follow this thing, right? So the third one is the URL, right? Okay, give me a minute. So now I'm still using this one, right? So let's say I did change to the infrastructure mode. I need to set the Java back to the normal. Okay, I need to be power recycle on my module. Right, you need to wait a while. So you will be see from here. After this one, they will find our AP. You will be see that this is a signal bar, right? This is a signal bar, right? So if you this one is become to our hardware addressing, right? You just refer to our one, right? So you just take note a few things now. Our REST API, we are not supporting all of the method. We are not supporting all of the method. We only support get, put, and patch. If you look at from here, is a lot of REST command method will be there, but we only support our hardware, only support get, post, and patch. So this URL, if you see from here, right, HTTP IP of your device, I want to read the DI slot 0. Let's say our starting is if you are using one device, mostly is our slot device, is the slot index is 0. If you want to be read individual channel, you have to URL will be different. So I just try to use the REST slot 0. I want to read all the input channel, digital input channel. If you click some send, you need to wait a while. So you will be see from here. Sorry. You will be see from here. This is the web server return value. 200 mean your reading is okay. All right. So this is all the JSON format. Their return, their payload, their return value they are using is the JSON. All right. So you will be see from here. As long as they are using is the DI, this is the DI value. This is the array they are giving to you is for channel 0 and channel 1. They are using is the array. Definitely you need to know that how to extract all this REST API, right? All the REST data. So you have to see, I'm trying to reading is the return value is the digital input. This is for the channel 0. Value is your data. Now, if you look at our one, is the UIPC from here is on. Value is on. I know why this value is off. Because if you, I'm not sure anyone know that why my input signal, even though I'm off, but my return value still keep on getting 1. Because our input channel, we are using is counter mode. That is the reason you are getting 1. Let's say if I toggle, I will prove to you whether this one is. Let's say if I toggle next time, this counter value, it should be 2, even though they are getting from the channel mode. Do you see that from here? Right? I'm toggling even though I toggle, this one, right? So because of this one, you really need to be careful. So this one also make me confused. Why I'm not on? Why this value is returning? Because our setting is we are using is the counter mode. That is the reason the return value is 1 and 2, right? So not 0 and 1. So you really need to be careful for this thing. This is my second simulation for the REST API, right? I'm not go through all the input output will be there, right? So the third one is I want to use for the MQTT, right? I did mention to you MQTT. They will have 2 client, MQTT client, and middleware we are using is the broker, right? So I'm using is this freeware MQTT broker. I just set up over here, right? So if you have the actual hardware, you also can be tested simple MQTT. I would say that definitely I'm not setting up very complex one. For this session, I just make it to be the simple and fast one, right? So this is for the MQTT. This is the link. You can get it from here, Google. So if this is the broker information, right? We are using MQTT normal TCP, all right? So you see. Maybe this one you cannot be able to log in because I'm running is the normal mode, 192.168.10.101, right? So the root 1, 2, 3, 4, 5, 6, 7, 8. So you see from here, right? Okay. So if you want to test for the MQTT, right? I'm using is third-party broker, right? You just go to our cloud setting. This is the cloud setting. They will have a few settings will be there, right? Greg did mention to you, if you want to publish your log data, your own Dropbox, you can use this one, right? You can refer, you need to choose this one. But for my MQTT setting, I'm using is the iSensing MQTT, right? So you will receive from here, right? This is the broker information, right? This is the port, exactly the same, right? So you just use all this information. You just set it up in here. A simple tab. I'm not using my one username, password, all these things, right? Definitely, you need to be set up something. Some kind of the security I also disable. I want to make it to be the fast, right? So you just set up MQTT. You just know the port and setting. So after you click apply, you just refresh this web page. You must see that the connected. Let's say you didn't see the connector or connecting all the thing, definitely you will not be working, right? So you must see that it's connected, right? So our voice 4012 is the MQTT client, right? So this is the broker information. I'm using third-party one, right? So client and broker, their connection is there, right? You must see that connected, right? You also can be tested to be the simple one, right? So the next step is how I can get all this data by using MQTT client, right? So, okay, I'm using this is the MQTT box. This is the MQTT box. So I just created created for the one of the MQTT box. I just double click that. You see from here the same thing. So if I want to get the data, right, we are not direct accessing to our voice module. Actually, is the MQTT box, MQTT client publish or subscribe. They just go to the MQTT broker, right? So protocol type is the MQTT. We are using is the TCP, right? This one is the protocol mode definitely have to be correct, right? So if you see from here, this one also the same thing, right? So you will be see that my laptop is the MQTT client. I'm running is the MQTT box, right? Our voice module, also will be MQTT client. Our web we are using is MQTT broker, third-party broker for this thing. We have three third party. One is the voice, MQTT broker, and my PC I'm running is the MQTT box, right? So the thing is MQTT also similar to the rest, but the terms they are calling is the different. They call the topic, but the URL is definitely you need to be have HTTP. They call the URL, but you don't have starting with HTTP whatever the thing, right? So they will call the topics very similar, right? You will see that very similar, but this one is this topic is defined by the Advantech. You will see that okay, this is for the Advantech hardware. So this is your actual hardware MAC address. You can get it from your hardware also, right? So all these device information you will be see from here, right? This is your MAC address unique 100D0 something. You have to be you have to be put it in here, right? I want to get it all this MQTT data, and then you just subscribe. Right. So, okay, one thing I forget explain to you. You will be see that my response time, I'm receiving the data. But my I forget to show to one thing to you. Give me a minute. So you see from here, right? If you went to set MQTT, we need to set this selection, right? We are using is the MQTT, right? Now is the MQTT, right? We are set it up, but we need to set it certain thing, right? Why we need to set that thing? Because you see now, right? If you just go to the advanced setting, you just go to the data log, right? You need to set up a bit there, right? So why you ask me, hey, why you need to set up to be the data logging? They have a few reasons. Grace mentioned to you is that our hardware itself internally they will have 10K of the storage data will be there, right? So let's say if your connection logs to the AP or your broker, whatever the thing, right? So our module itself they will log for you according to all these conditions. According to all these conditions, I just set it up to be there. Every 5 seconds I want to be logged. That is the reason if you are running MQTT bot, every 5 seconds they will publish the data. Right? This is not just the publishing. This one is the log. You will be see from here. These two steps is the important. Set up the MQTT, set up to be the data log. This is the main important one. Even though you log, you set up, you didn't set up enable to be the publish notification, your data will not be go out. Right. So you if you have a hardware, you can replay all this kind of the setting. Right. So this push notification you have to be enabled, right? Otherwise you will not be receiving any MQTT data, right? So you see from here, right? This is the topic. If you want to be, this one is for the subscribe, right? This one is for the subscribe. Is the you try to reading the data. We call it subscribe. Publish is this one. I want to give the comment or I want to share your data to other thing. We call the publishing, right? So you see from here, right? I will try to Sorry, I will try to show something to you from here. Right. So now is I want to trigger. I will use the MQTT publish to trigger my data. Right. This is my URL. This part is the same. Advantech MAC address also the same thing. Because I want to control my DO. All right. This is the you have to put in CTL. CTL means we call the control. So you need to take note. This thing is DO. I want to control DO1, DO2. So this one you will make you a little bit confused. Right. So in our labeling, we are saying is the channel DI0, channel 0 and channel 1. But if you want to give comment from the MQTT, your channel 1 is not starting from 0. You have to use, okay, I want to trigger channel 0. You have to set DO1. And then your payload, you want to change the value also. The rest of the thing I'm not touching, right? So you just keep true. You just keep publish. You will see that this LED will be on. All right. So if I want to trigger channel 1, what is there one? Is there saying that DO2? Trigger again, you will see that another LED will be on. Right. So this one is if you can use the MQTT file to simulate. If I want to be false or true, you just change the payload, the value. You have to change the value. Okay. So I think this is my last simulation for the MQTT. Okay. Maybe I will release my sharing to my next colleague.
Good afternoon, everyone. I'd like to share these some application story. Okay, so this is what they based on this WISE module. So from here, we will see that the customer actually very interested to be use of this Advantech this IoT solution. So in the past, the client with this battery information, they always having some limitation. It means this operation information is always at this ground level. In order to be pass this operation information up to the top level, it will taking about weeks or months. It depends on the person who do the reporting or do the recording. Even though there's some information, it's still subject to the manpower to be transferred either by the enter to the this information to the system or manually pass the information to the top level. So for this Advantech IoT solution, it can be overcome. This is a limitation. Okay, I'd like to share that the purpose of this IoT solution is to meet the client requirement. It's important for this the client to know that the ground level, what's the status on the machine, the production, and even the throughput, so that it can be understand the whole overall of this production. So the solution is to be reflect this operation technology information up to the information technology. Yeah. So that means we can be transfer all these ground level information. Let's say, for example, those are sensor, motor, actuator, those kind of information to become a digitalized, so that on the top level they can aware that whether the machine is working as a normal condition or the production is functioning as a usual. Yeah. So and it can be monitored by this remotely from the different location, because all this information have been digitalized, so that it can be monitored from anywhere. And in the past, because it heavily depends on the manpower, this information, it can't be immediate to be monitored. But right now, with this Advantech IoT solution, especially with this WISE module, to help out to this client, so that it can be overall monitor the factory this production information. It also can be increase the efficiency of the production and output. From here, we will saw that there's a WISE module 4010, which will be connected to this sensor. The client want to monitor this machine status connected to the sensor, so that it can have a third party of the sensor to be mounted on the machine, and it can be direct transmit all this sensor information all the way to our this UNO 203, and this is our SCADA system, which you can be let the client to do their own design, their own this graphic user interface, so that you can be have a overall view of the production information. And you can see this WISE module, it can be allocated at different location. From here, we can see there's a location 1, 2, 3, different location, and also it can be monitored with the different kind of sensor. So from here, we see the location one. Actually, the sensor is to be monitored. This analog signal is a 4 to 20 million, and all is can connect up to 4 channel of the input. Yeah. Okay. So we'll come to the detail this application. Okay. From here, that you can see that for this case, because this 4 station is allocated to be nearby each other, so individual of this station will be installed with this third party of the sensor, and the sensor will be monitor this floating of this water. The floating of the water and the pressure could be very crucial, because without this information, the client noticed that sometimes without the correct level of the floating, it will be affecting this quality of the product. So with this WISE module, so you can be tap all these analog from this measurement or to our this WISE module, so they can be transfer all this information to our this SCADA. Then from the SCADA, we can be alert that the user whether there's a correct flow level on this station. Yeah, and as you can see, this is a WISE module, which it can be connected up to 4 current input, and it also allowed to have the 4 digital output. It means if let's say the client prefer to have some signal tower, then or the signal light, so that it can be do some coding on the SCADA system to trigger that this station having the issue, then it can give the alert to the operator or to the technician to take a look on this station, and also to be rectify the station before when too many products have been affecting. So this is one of the advantage which can be used for our this Advantech WISE module. And this is a good thing is it comes with the length, so that means the speed, the response will be quite fast. Yeah. And I would like to share that for this UNO 24F4 actually is our this is a IPC, which are bundled with the 4,500 tab of the SCADA. So it's a very economic price for this client to be monitor the plant information, actually to those stations which are located at this control room. And you also allowed to be share this information either by the client this cloud service or to this our this Microsoft Azure cloud service, and it also allowed the user to be customized the graphic want to be monitored. For example, you can see this as a bar, there's a different chart can be customized and designed by the customer. And from here, we can have the second application. Then this is to monitor the tank level and the pressure. For this equipment is crucial that they know that this tank it can be monitored from either a low level or high level, and for this time we are using this Eden 6250 because they has this is come with the this sensor is come with the digital signal. So and our this Eden module have 8 digital input, which I think more suitable for them. And it could be because some of the machine could be not only 2 tank but also have a 3 tank and 4 tank. So that means we can be standardized with this module, regardless it's a 2 tank or 4 tank. Yeah. And beside that, we also have this WISE 4010 because the sensor they are mounting is also monitor the pressure, and the pressure will be connected with one of the third-party sensor, so that you will provide this 4 to 20 milliamp. From there, we can do the proper scaling, so it can be reflect the correct information from our this UNO 24A4 SCADA system. Yeah. So I would like to share that for Advantech, we have we have a different kind of either is a wireless solution or wired solution. So from this application, for example, the customer, so for a certain area, they're having this power source connection, or there's a limitation of the space, then we can have a propose a different kind of interface solution. For example, on the left-hand side, we are using the Wi-Fi, so that it can be less wiring. You no need to be pull or redo some wiring for the LAN cable all the way from the end to the other end. So so for this Wi-Fi, so it can be hooked up to even our this industrial Wi-Fi router, so that it can transmit all this information by the Wi-Fi. And as you can see that we also have the LAN module. So from here is for those area which are nearby to this our SCADA system. So the LAN will be suitable, and also it can be transmit high this information with the faster response. And if let's say there's some further area and you want to be monitored from our this SCADA, the LoRa will be another solution which are very suitable for our client. For example, the client having the very wide space or the big plant, and LoRa is very suitable. And it can for Advantech, we have the 2 different kind of sensor. One is a vibration sensor, the other one is a current transducer, and one more is this WISE 4610. So all these product is come with this LoRa interfacing. The good thing is that it can be transmit with the long range. Yeah. So and okay, I would like to share the vibration sensor actually is to be mounted on this so-called this equipment compressor. The purpose of this is to be monitor the compressor to make sure the compressor is well maintained, and make sure it's in the good condition to be operate. If let's say the motor is wear and tear, I mean internally the bearing, all these wear and tear, then the vibration will be start getting different compared to the normal situation. So they also able to be give a technician a very good of view when to be do the overhaul of this compressor. And beside that, we have this current transducer sensor. This is to be monitor the current of this compressor, so that you can be aware that what's the power source, power consumption from this compressor. And lastly is this WISE4610. It can be connected to either the current input or digital output. So let's say you have some of the device with sensor or can be provide the current input. You can use connect to this WISE module, and it can be transmit from here to all the way to this SCADA. One thing to take note for this LoRa solution is required to be bundled with this LoRa gateway. And this LoRa gateway, it can be for this WISE4610, it can be connect up to 100 device of this LoRa device. So from here, that we know that based on the different environment, based on the different application, and also based on the different inquiry, Advantech is able to be propose this suitable solution for them. Yeah. And lastly is let's say the area is very hard to be do some additional work, for example the LAN or additional hardware, then the LoRa will be the very good solution for our client. From here that let's say all the machine is installed at the far away from the control room, then it can be using this LoRa device. And this I think I have been speaking before. This WISE module, it can be connected up to 4 channels of the current input. And let's say this on the left side, you can see that the temperature sensor, if let's say, can be able to be provide the current output, then the LoRa WISE 4610, it can be compatible with this connect to with this temperature controller, and it can be do the proper scaling from our SCADA system, so that it can be monitor the actual temperature from this machine. And similarly for this pressure gauge, it can be in the current output, so you can do the proper scaling and you can monitor all the individual pressure gauge, so that it can be alert the technician whether when to be refuel the tank. Yeah, and basically from here we know that regardless of which kind of the inquiry, whether it's by the Wi-Fi, by the LAN, or by the LoRa solution, all our this UNO 2483 with this SCADA system, it can be receiving all these different device information, and the client can be customize their own graphic and this machine status. Yeah, and it can be monitored from here. This is my last page to be shared on the application. Thank you, everyone.